Welcome to Data Structures and Algorithms. Today let's learn how to analyze the space complexity of an algorithm. Time complexity tells us how the amount of work grows. Space complexity tells us how the memory usage grows with the input size. Memory can be used by variables, arrays, data structures, function calls, and temporary storage. Consider this simple algorithm. It processes n numbers but only uses a few variables. The number of variables stays constant regardless of n. Therefore, its auxiliary space complexity is big O of 1. Now imagine creating an array containing n elements. As n grows, the memory required grows linearly. So the space complexity is big O of n. A two-dimensional array with n by n elements requires n squared memory locations, giving big O of n squared space. As a quick guide, constant extra storage gives big O of 1. An array of n elements gives big O of n. And an n by n matrix gives a big O of n squared. There is also an important distinction between the memory usage to store the input and the extra memory an algorithm needs. Auxiliary space refers specifically to the extra memory used by the algorithm beyond the input itself. So, time complexity measures computational work while space complexity measures memory requirements. Remember, to analyze space complexity, identify the memory used and determine how that memory grows as n increases. In the next episode, we'll compare time complexity and space complexity and explore the trade-off between them.